Hello, good morning students. So today we'll be discussing from the chapter database concept on relational algebra. So I hope that you have understood from the tutorials links the relational database RDBMS. Okay, I've uploaded those categories also, that is like one to one to many to many. Okay, you can search for some more links and also from Google search. Okay, you can find many ebooks related to that, and also view of data. So three views of data: external view, conceptual view, internal view. External view has the highest level of abstraction that you have seen. Okay, and also data independence, that is logical data independence, physical data independence. Okay, then also I refer to you about the relational data modules, hierarchical data modules, and network data modules. uh, Out of that, the most popular one and widely used is the relational data model. This is the easiest data model because the data are stored in the form of relation in a table format, so in a 2D table format. So based on that relational data model, uh, it has different properties, such as like the relation or the table, right? So there are some certain properties associated with a relation or the table. Just go through this is very easy to understand. Okay, and then domain. So domain, that is also that was discussed. Okay, a pool of values from which the actual value present in a given columns are taken. So here an example: teacher number shows that the T number is taken from this one, is taken from the all valid teacher numbers, that is T01, T02. So base domain is so like a range of values, okay, taken from that column. Okay, based on that column, suppose like here T name. Okay, T name or S name. Now you know that T name, it relates with characters, right? So based on that, it will have the data values, character values, and subject also. But suppose like age. Now age can hold integer values only and positive number values only, right? It cannot hold, age cannot be in negative numbers, or age cannot be in zero. So age has to be from age 1 2 3 later, right? So that is the domain. Okay, so columns, rows, degree, the number of attributes, that is the columns. Okay, cardinally, the number of rows, that is the tuples. Okay, so all these things, just go through this once again. Okay, so today I'll start on this relational algebra. Okay, so there are some things explained in here. So relation algebra is used to perform specific operations on existing relation to provide desired results. Okay, so to perform specific operations on existing relation, that means to perform some mathematical operations, okay, on a relation or a table, okay, on one or more tables, okay, so that to give the output. Okay, so here the input is in the form of a table. Okay, so using this relational algebra, okay, it will process on one or more tables, okay, using some mathematical symbols, okay, and then get the desired output. So this relational algebra is part of the DML, that is data manipulation language, okay, which you see later on. Okay, here we use the query keyword select. Okay, that is so here a relational algebra is the following components, that is operands, okay, which is a relation or variables. Okay, so uh, multiple variables that are represented are called as operands. Okay, this I think these names, I think you're familiar with that in the operator chapters also, right? So operators, so there are some like said some mathematical symbols that will be used to equate on the table or the relation. Okay, so the rules for combining the variables and the operators, okay, and then rules for evaluating those expressions, the expressions that has been formed. So like these expressions, okay, so there is some procedure for evaluating those expressions. You cannot write those expressions randomly, so there is a procedure of writing that format also, right? Just like in C++, there is a format of syntax, format of writing the programming language, right? So similarly here in also relational algebra, okay, there is a format on that. So here operations of relational algebra, it includes the following: union, okay, we'll see all those things one by one. Union, intersect, uh, set difference, Cartesian products, okay, which are based on set theory, and select, project, join, division, okay, which is a operation developed specially for relational database. Okay, so these are some of the symbols that will be used. The first one is select operation. So this is a unary operation, so which means that, okay, it will be this select operation, or in select operation, okay, this is based on a single table. Okay, here we use the symbol sigma. So select some tuples of the relation, okay, the selection operation yields a horizontal subset of a given relation. So this select operation, it selects rows or tuples, okay, that means in a horizontal format, and gives the desired output in a horizontal format. Okay, so if you see here, okay, the selection is denoted by lowercase Greek letter sigma. Okay, so this will be this symbol used for the select operation. Okay, so sigma. So select in the case like uh, you can use it like input values. Okay, or select means, okay, yeah, accept those values like that. So here if you see in this student table, this table, it has the roll number, it has the name. So all the roll numbers are different and all the names are also different, right? So now there's a condition that here, okay, so that condition has to be satisfied here. So example, to select those tuples from the table student whose roll number is greater than 103. So from this particular table, okay, you have to select this. The table name is student, it has two columns, okay, or attributes roll number and name. This is also called as fields, okay. So roll number fields and name fields, and these are the data values, so column wise. So here you have to select from the student table whose roll number is greater than 103. So those students whose roll number is greater than 103, so you have 104, 105, 106. So this is actually the desired result you should get along with the name, that is Kumar, Jimmy and John. Okay, so how do we get this output? By using the relational algebra, that is select sigma. So it's very easy here, okay, very easy to understand, very easy to forget also, okay. So sigma roll number greater than 103 within the bracket student, okay. So what this means is that select, okay, from student table, okay, the column roll number, uh, the data from the column roll number, okay, which is greater than 103. Okay, so it means that sigma means select. Okay, so the so select in English, okay, so it means select, or you can say like in other words like input, okay, or search. So here this select is associated with the column name, that is roll number, because here we have to search from the uh, student table from the column roll number who is greater than 103. So this column is the condition. Based on this column condition, that is 103, okay, greater than 103, you can select the names also. So if it is greater than 103, that means 104, 105, 106. So based on that, you get Kumar, Jimmy, and John. Okay. So here, this sigma is select is attached with the column name, and this column name has is as the condition, okay, which is a boolean expression, okay. So based on that, either true or false, okay. So roll number is greater than 103, so we have to search for that in this table. So the column will always be associated with a data value from that particular column only. Okay, so is roll number greater than 103 from the student table. Okay, so within this bracket the student table here is mentioned. Okay, so if suppose the question was like roll number is greater than equal to 103, right? So in that case here, in the greater than symbol, we'll also use the greater than or equal to, we'll put one dash here. So sigma roll number greater than equal to 103 from the students. Okay, so as I said, okay, easy to see, okay, easy to read, okay, but easy to forget also and get mixed up. Okay, so this is an expression that has to be evaluated. So similarly here, this sigma, okay, or this select operation can also be used for relational operators. In this case, this is a relational operator, okay, greater than, less than, okay, greater than, equal to, less than, equal to, like that. And also it can be used on boolean operate logical operators. So logical operators which similar to the ones that we use in C++, okay. And for logical operators and or, we use the symbol, this symbol, okay, where n is denoted by this, okay, and or is denoted by this symbol. Okay, so here if you can see in this particular example, select the table from table student, we have to select tuples whose roll number is greater than 100 and less than 105. So from this table we have to select roll number greater than 100 but less than 105. So that means we will exclude uh, two roll numbers, that is 105 and 106. So that is 100, 101, 102, 103 and 104 for 104. Okay, so based on that, okay, sigma roll number greater than 100 and 100, okay, you need roll number less than 105. Okay, so since there are two conditions, so that's why the column name is associated with the data value, and also based on this logical operator, that column name is also associated with that value, just like in C++, how we use the logical operators. Okay, so next we have is the projection operators. So just like a select operation, the projection operation is also used in the same way. Here we use the symbol pi, okay, the math symbol pi, and in this case the output is generated in the form of columns. Okay, when we want to produce the output, okay, in the form of a column, okay, so we use the projection operators. Okay, so here in this particular the same table here, roll number, name and marks table is there, right? So you can see that two of the marks are same. So in projection operation, what happens that the duplicate rows are removed. Okay, if there is any duplicate row in the table, that is removed. Okay, that duplicate data is removed. So here, based on that, suppose we have to select the names of those students who scored more than 250. So now in the student table we have to find the students who scored more than 250. So there is Vivek, there is Puneet, there is Kumar, and there is John, right? So based on that, the condition is pi name. So now here, since we have to search from the name columns, right? That means this is same like the select statement. Okay, so select or display from name. Okay, pi means display from name. Okay, based on the condition within the bracket. Okay, sigma, that is this sigma select. Okay, sigma marks greater than 250. So this side of the condition is same as this. Okay, so sigma marks greater than 250 from the student table. Okay, so that based on that, if the marks is greater than 250, by name it will display those name lists. So this name list will be displayed. Okay, similarly, if you have to display the marks by marks from the student table, okay, so it will display these marks, but the duplicate row 210 will be removed. Okay, so that duplicate data gets removed and you get to display only the single value marks. Okay, so this is how you use the projection or operation. Now if we have to come to the union operation, okay, the union operation, what it does is it combines two or more relation. Okay, it combines two or more tables. So the projection and the select operation both are uh, binary operations, so based on only one table. But from here, union operations, since it can process on two or more relations or tables, so this becomes a binary operation. So here also the duplicate tuples gets removed, the duplicate rows gets removed, and this U symbol signifies the union operation. Okay, so there are some conditions. Okay, that is both the relations are of the same degree. Okay, so that means the number of columns in one table should match with the number of columns in the second table also, and the domains of both the relations should both the tables should also be same. So in this case we have two tables, that is student and student one. As you can see, the roll numbers, two roll numbers gets repeated, that is 10, two rows gets repeated, 103 Puneet. Okay, 103 Puneet and 106 John, 106 John. So as you know that in union operation, that means union, same like maths, this and this table, the union of this, okay, it will remove the duplicate rows and it will combine these two. Okay, so if we write here sigma student union student one, okay, this table will be produced, the the combination of these two tables. Okay, only thing that you'll observe is that the name Puneet is repeated only once, same Johnny is repeated only once, though they are repeated in both the tables. Okay, so the common tuples gets eliminated and all the remaining single rows tuples gets written. Okay, so it combines the two tables. Similarly, intersection operation. Intersection operation is just like quite the opposite of the union. Okay, it it from it is also a binary operation. So what it does is that it returns the common tuples from both the tables, from both the relations. Okay, so whichever names are repeated, so here Puneet and John, right? Puneet and John from the two tables. So when you execute the formula, okay, student intersection student one, sigma student intersection student one, okay, then it will yield these results, because from these two tables, okay, this Puneet and John's gets repeated here and here also. So the common tuples, the common rows from these two tables will be the one that you get in the output. Okay, now another one is the difference operation. So in difference operation, what you do is that you use this minus symbol. Okay, in difference operation, when you say like student 1 minus student 1, okay, sigma student minus student 1, then what happens is that the it removes, okay, the tuples from the first table. Okay, so in this case, if you see the results of this difference operation, okay, so here this is the first table and second table. So student sigma student minus student 1, you can see that, okay, Prakash, Sudhakar and Jimmy is written here, but Puneet and John is not there. Okay, Puneet and John is not there. So Puneet and John is repeated in here also, right? So from the first table, it removes the common tuples. Okay, in the difference operation. Okay, so from the first table only, not from the second table. Okay, student minus student one. What the in terms of difference operation, set difference operation, it will remove the common tuples, the common rows from the first table after comparing the first table and the second table. Okay, so that's why you are getting Prakash, Sudhakar and Puneet here. Prakash, Sudhakar and Jimmy, sorry. Okay, because Puneet and John is repeated in the second table. Okay, so the second table in this set difference is just used for removing the duplicate rows in the first table. Okay, the remaining data, that is rows, that is in the second table, that is Vivek and Vivek, okay, will not be displayed, will not be written down. Only the first table data will be displayed. Okay, similarly Cartesian product, this is also a binary operation. Okay, here between two relations, okay, between two relation there will be the concatenation between the two relations. Okay, so it is denoted by the x symbol. Okay, and here the degree of new relation is the sum of the degree of two relation on which Cartesian product is operated. Or, okay, if you see here, number of tuples of the new relation is equal to the product of the number of tuples of the two relation on which Cartesian product is performed. So here you have two tables, student table and teacher table. Okay, Cartesian product, what it does is it concatenates these two tables. Okay, these two tables. So what will happen is, okay, the number of tuples in this table, okay, and the number of tuples in this table multiplied will be equal to the new table that is created. Okay, so which means that here how many tuples are there? Three tuples are there, right? One first row, second row, third row. Here how many? One, two, right? So 3, 2, that means 3 into 2 will be 6, right? So in the new table that is created out of the student and teacher table, a new table will be created. So in that new table there will be 6 rows of data, that means 6 tuples will be created based on this. Okay, number of tuples of the new relation means of the new table, okay, is equal to the product of the multiplication of the rows of the two tables. Okay, so that's why you get here 6 rows of data. So if you see Vivek, Puneet, John, okay, here, and then Nayak, yeah, Nayak and Kovin. Okay, so here see Vivek, okay, Puneet, John, Nayak and Kovin. So here you can see that duplication of data is there, right? So if you count the number of rows, 1, 2, 3, 4, 5, 6. Okay, so that way concatenation between these two tables exists using this Cartesian product, right? So next we have is the join operation. Now in join operation, okay, here you have two tables. Now this join operation also results in duplication or redundancy, unwanted data. Okay, what happens is that these two tables will be joined, okay, along with the columns also. So this here you have roll number, name, city, T number, T name, T city, right? So in join operation, what will happen is that these two tables will be joined. That means all the columns based on a similar column data. Okay, here the column name is city, here the column name is T city, but the data here is Delhi, Mumbai. Here the data is Delhi, Mumbai. So based on the data value between data that is associated with a common column, okay, the this table and this table gets combined. So if you see the results of this join, or in this case it is called as equijoint. Okay, so this is an equijoint result. So here you can see that the roll number, name, city from this table, and teacher number, teacher name and TCD from this table. But you will see that here 106 John Kolkata is not written here, because in the other table Kolkata city is not mentioned, or uh, 106 or John is not mentioned here. Okay, because Delhi and Mumbai is written here. Okay, and they both are same. Okay, that's why this row and this row gets repeated and joined in here. Okay, so this is actually unwanted unnecessary data formation. Okay, so based on that you can also remove the duplicate columns, okay, data, based on what is called as natural join. Okay, so if we have to delete duplicate columns during join, then the join is called natural join. Okay, so it will be denoted by this symbol. So if you see this the resulting table, you have the roll number column, you have the name column, you have the city, you have the T number, you have the T name. Okay, but you can see that only one of the command column is written here. So one of the column, either CD or TCD can be removed, and only one of the column can be written. Okay, so this is the format of natural join. Okay, so you for better understanding, okay, you can search more for examples from YouTube or from Google. Okay, because in this textbook, okay, this is the only example as far as that is given in here. Okay, so this is a very small section in the database concept. Okay, and in these pages only, these contents are here. Okay, so you can refer from this, you can study on this. Okay, and it is not much implemented in this database concept in this particular textbook. Okay, so only in this these details are given here. So based on that, the rest keys, primary key, foreign key, these are repeated in the rest of the chapters also, and this is implemented in the rest of the chapters also. Okay, so go through this relational algebra once. Okay, try to understand it. Okay, based on these particular examples. Okay, so that will be all for today. In the next class, I'll be discussing on the keys.